7.3. Thanks for watching. Thanks for tuning in. Let's jump right into it. 7.3 is going to feel like a complete deja vu of 7.2, to be honest, right? A review of 7.2 just like in 20 seconds, right? If there's a factor on top and that same factor is on the bottom, well, then we can just cross those out and we're left with this. You probably were more so struggling with the factoring than you were the crossing out, right? Factoring is a skill that we got to keep getting better and better at. But this right here, this idea, if it's on top and on bottom and cancels out, is the underlying theme of all of this today, okay? So let's take a look at this expression. We don't exactly have factors, we just have these individual terms, 12, the x squared, the y. But guess what? If there's a y on top and a y on bottom, they're going to cancel out. Real quick though, I think it will be a little easier to see what cancels out if we combine them together. So 12 times 2 is 24, x squared times x is x cubed, y times y is y squared, 5 times 3 is 15, and then we've got x squared, y squared. Now that I have it all grouped together, I feel like that just makes it a little more obvious as to what's going to cancel out. I can see that there's two y's on top and bottom, so boom, that cancels. I can see that there's three x's on top and two on bottom, so two of them will cancel and we'll be left with 1. And then 24 and 15 are both divisible by 3. So I'm left with 8 and 5. So in the end, I have 8x over 5. And that's it. So if it's the same on top and bottom, it cancels, it cancels, it cancels, it cancels. Let's keep it going. So here, we actually have to factor. So let's factor. We've got x times x minus 2 all over. And then, so again, I looked at this and I said there's a GCF of x. So I yanked out an x and I'm left with x minus 2. Here, I have 3 terms, so I'm saying to myself, what multiplies to 1 and adds to 2? 1 times 1 is 1. 1 plus 1 is 2. Times, okay, take a look at the next set. What multiplies to 3 and adds to 4? 3 and 1. 3 times 1 is 3. 3 plus 1 is 4. All over. And then the last term. Again, why do I look at this and know I need to find a GCF? Because there's only 2 terms, and they both have x, right? If there's a GCF, you need to take it out. So because I take out this x, I'm left with x plus 3. And like I said, anything that's the same on top and bottom is going to cancel out. So there's an x plus 3, there's an x plus 1, and there's an x. And I'm left with x minus 2 all over x plus 1. And notice, let me go back a few moments there. Notice even these two I crossed out, right? Even though one was on the left and one was on the right, because we're multiplying, it's all going to mush together anyways, right? So even if it's on the left and one's on the right, it's still going to cancel out. Like so. Another example where there's just a bunch of terms, maybe you find that multiplying it together is a little bit of a waste of time. It's fine. Just cancel out what you see here. This cancels out with this. I'm left with 3. I see that I have 5 y's, so I'm left with 2. And then I have a y here, so I'm left with 2 there as well. And then I have an x, so that crosses out with that. So I'm left with 2x cubed y to the 4th, because there's 4 y's, 3 x's, and a 2 left over, all over 5 times 3 is 15, and all the variables crossed out. And there it is. Let's do another one. I'm moving quick, but feel free to put me on slow speed or to rewind, right? I've only taken about 4 minutes to do these 3 problems. Hopefully the video's short and maybe you're willing to repeat it a few times to learn. There's 3 terms, so I know I'm factoring normal style, and by normal I mean what multiplies to the last term and adds to the middle term. That would be positive 3 and negative 2. 3 times negative 2 is negative 6. 3 minus 2 is 1. And 2x squared is just chilling. Times, again, there's only two terms. I know that they're both divisible by 2. So that's my GCF, and I'm done. All over, what multiplies to 12 and adds to 7? 4 and 3. I'm coming up with the numbers 4 and 3 and 3 and negative 2 pretty quickly. Just make sure that you agree with that, right? Does the combination work? What multiplies to 12 and adds to 7? 4 times 3 is 12. Yes. 4 plus 3 is 7. Yes. Cross out what is the same. And I've got x minus 2 over x squared. And we're done. So, switching gears a little bit, and we're doing division. Division, when you divide by a fraction, that's the same thing as multiplying by the reciprocal. Dividing by a fraction is the same thing as multiplying by its reciprocal. So, with that being said, that means this is the same thing as... And now this problem is just another multiplication problem. I kid you not, right? Dividing is the same thing as multiplying by the reciprocal. So what I was just doing for these 4 problems is the exact same thing I'm going to do for these problems, right? Because dividing is the same thing as multiplying by the reciprocal. So I'll do one more just for good measure, and then I'm going to start to ask you some questions. So we've got x squared over, what's x squared minus 1 factored? There's no GCF there, right? They're only divisible by 1. So when I had 2 terms, right, I was like, well, find the GCF. When I had 2 terms, I said, well, find the GCF. Well, there is no GCF here. This is a difference of squares. So it splits into x minus 1, x plus 1. You can ask yourself, what multiplies to negative 1 and adds to 0? Because there is no middle term. What multiplies to negative 1? Negative 1 times 1 is negative 1, and negative 1 plus 1 is 0. Times x plus 1 over 3x. So an x plus 1 cancels, and an x cancels, so I'm left with x over 3 times x minus 1. Beautiful, right? All right, so I'll give you your setup here. This is the same thing as multiplying by the reciprocal. So there's that setup. If you would, go ahead and factor the top and bottom for me. I'm gonna ask you to factor the top. Okay? So you factored the top. You answered that question. You should have got x, what multiplies the negative 22 and adds to negative 9. That is negative 11 and positive 2. Negative 11 plus 2 is negative 9. Negative 11 times 2 is negative 22. I only asked you for the top, but the bottom is what? Positive 8 and negative 3. 8 times negative 3 is negative 24. 8 minus 3 is 5. Okay, the problem that I'm about to ask now is multiple select, and I want you to tell me which factor or factors are going to cancel out. It's multiple select, so choose all of them. Okay, so you just chose which factors needed to cancel out, and what were they? The x minus 3 and the x plus 2. And you're left with x minus 11 over x plus 8. Beautiful. Good job. Let's keep it going. Again, dividing by a fraction is the same thing as multiplying by its reciprocal. So this is the same thing as multiplying by x squared minus 6x plus 8 all over x squared minus 2x. And then you factor, and whatever's the same on top and bottom cancels out. We're doing the same thing over and over. Let me ask once again, what will the bottom of this fraction factor into? What did the bottom factor into? You just answered. Hopefully you chose the right answer. They have a GCF of 3, and you're left with x minus 4 when you divide out the 3. Times, let's just do back-to-back questions. What does the top of this fraction factor into? Boom. Okay, hopefully you answered it. It is x. What multiplies to 8 and adds the negative 6? That's a negative 4 and a negative 2. Two negatives. Negative 4 minus 2 gives you negative 6, but the two negatives multiplied together give you a positive 8. All over, and they both share an x in the denominator. You're left with x minus 2. And you cancel out what is the same. The x minus 4, the x minus 2, and there's an x, and you're left with literally just 5/3. How about that? This might throw you for a loop a little bit. This isn't a fraction. At least it doesn't appear so. What is the fraction? Well, you can write anything over 1. You can write anything over 1. So that's exactly what we're going to do. So when I rewrite this, times 1 over 2x cubed plus 3x. Again, we want the multiplication problem because then we can easily cancel out what's the same on top and bottom. So I factor this guy. Ooh, that's going to throw us for a little loop because a is not 1. You might remember from the last video, I showed you the little trick to take the front times the back, right? We did that in Unit 4, I believe it was, but I showed you the little trick again to take the front times the back, and you get negative 18. And then you ask yourself, what multiplies the negative 18 and adds to the middle term of 7? The magic numbers there are positive 9 and negative 2. So this is just some scratch work here. I'm not going to jump straight to the answer quite yet. So that turns into 6x squared plus 9x minus 2x plus 7. Remember, I called this splitting the middle term. So I split the 7 into 9 minus 2 with those magic numbers. Then I look for the GCF of the first two terms, which 6 and 9 are both divisible by 3. Also, they both have an x. So I'm left with 2x plus 3. And then I look at the GCF of the second two terms. I accidentally wrote 7 here. That was minus 3. That's my bad. Get the right color. The GCF of the second two terms, well, they're both negative, so they share a negative 1, and I'm left with 2x plus 3. So the final factored form is you take the first two terms, and you take the term that matches, and boom, voila, we're in factored form. And then this guy simply has a GCF of x. If you have to go back and watch that again, so be it. But the quick recap is you take the front times the back, and you get negative 18, and you ask yourself what multiplies to that number and adds to the middle term. Those two numbers were 9 and negative 2. So I used those two numbers to split the middle term, GCF for the first two, GCF for the last two. All right, so we continue on. What's the same on top and bottom and whatnot? Here, how about I ask you another question right here. Go ahead and just cancel out what needs to be canceled and choose the correct final answer that's on the screen, okay? So what did you end up choosing? Well, you should have canceled out the 2x plus 3, and that's all you can cancel out. So 3x minus 1 times 1, that's 3x minus 1. all over 6x squared and x combined to be 6x cubed. And that is my final answer. All right. For the sake of time, right? These are rather repetitive, right? These are rather repetitive. Here, it's just three things being multiplied and divided together. Just stay on top of what is division and what is multiplication and take care of business. Is there one that looks harder than all the others? Not particularly. My eyes are gravitating towards, let's say, this one. My eyes are gravitating towards that one. I'll do one of these, right? I don't really see a point in doing all four because it's just the same thing over and over. I've already done it 8 times. Let's do it one more time here. So x over x plus 5 times, okay, so that guy I leave alone, right? That guy I leave alone because it is multiplication. But this one I'm going to flip because it's division. All right? I need to factor. Nothing to factor in that first thing, right? These are lonesome factors, lonesome factors, lonesome factors. It's only this that needs factored. And the reason why this stuck out to me is because of that guy right there. How does that factor? It's a difference of squares. Google that phrase if you need some practice with difference of squares. There's probably about 20,000 YouTube videos called How to Factor Difference of Squares. Why is it called a difference of squares? Because these are perfect squares. So you take the square root of each of them and you do plus and minus. Right? That's the pattern that we took note of in Unit 4. You take the square root of each of those guys, plus or minus. 3x minus 5, 3x plus 5. So, what cancels out here? 3x minus 5, x plus 5, and that's honestly it, right? So there's an x left on top, and there's 3x plus 5 on bottom. All right. The very last question, and we're going to be under 20 minutes. I'm incredible, right? Don't answer that. So, one last question here at the end, too. Volume equals area of the base times the height. So we need to find the area of the base and then multiply it by the height. You remember this from geometry, right? I know this is the box right there, but here's the base on the bottom. And then imagine stacking a whole bunch of rectangles on top of one another. All of a sudden, you create a prism, which is why we're doing the area of this base and then multiplying it by the height, right? So they're telling you here that the volume is this and the area of the base is this. Let's fill in the blanks of the equation. Volume, x squared minus 14x plus 48 over x squared minus 6x equals area of the base, well, that's 3x minus 24, times the height. Now, how do we solve for height? You might look at this and go, well, this looks overwhelming. What if I told you the volume was 30 and the area of the base was 3? What would the equation be? Volume equals base times area of the base times height. That'd be 30 equals 3h. What would you do to solve for h? You would simply divide by 3 and you tell me, oh, the height of the prism is 10. That's exactly what we're going to do here. Divide this away. Well, when you divide, that's the same thing as multiplying by the reciprocal. So if we just divided by 3x minus 24, that's the same thing as multiplying by the reciprocal, and that equals h. right? I hope you see the comparison that I'm trying to make here. Even though this feels almost like gibberish and there's all these x's going around, just think of it as one term equals this term times this term, right? Just like this. Even though they aren't numbers, the math still operates the same. So, in the end here, what do we get? Tell me one more time, factor for me one more time here. What does that factor into? All right, 45 more seconds to finish this. You just answered the question. The video's almost over. This is x minus 6 and minus 8, two negatives, over x times x minus 6. They have a GCF of x. Times 1 over, they're both divisible by 3. So x minus 8. So when you cancel everything out, bye-bye, bye-bye. The answer is just 1 over 3x. That is h. H is 1 over 3x. Thank you for watching. If you'd like to see any more of these examples, please be sure to chime in the chat in class and we can talk about any of these three if you need to see a few more. Thank you for watching. Until next time.